Good afternoon everyone, this is Hemant. I'm an Impact Support Engineer here at StruEngineers, and today we bring you an instructional webinar on creating Endcaps and CIM templates and also applying them to the walls. So I think let's get started. It's a briefly info about me. Now the overview of the Impact. So Impact works on the main database that is hosted on the SQL server, and being a cloud-based service, all the people working on this project and software can access and work on projects from anywhere in the world, and the various softwares involved with the Impact are listed here. So we can work with Tekla, Revit, AutoCAD, Precast, and our native software program project manager. So I think that will be all for the Impact. We'll be jumping on to the main topic, that is creating Endcaps and the CIM template in Impact Precast. So our rough agenda today will be creating the product Endcaps in Impact and adding the reinforcement and CIM in those Endcaps. We'll be creating CIM template in the Impact for AutoCAD and applying this Endcaps and CIM templates to the elements such as walls, slabs, and hollow cores. Our approximately duration will be 30 to 45 minutes. So let's get started with the project manager. Here I have already started with one of the project, and I will open up floor plan. In this floor plan I have added some of the elements so that we can save some time, but we will get started with this. Now before defining the Endcaps, we should create a new drawing in others so that we can distinguish the components from the others. So I will open up this particular Endcap drawing. And here I will add a little bit of partition so we can distinguish between solid wall Endcaps, sandwich wall, and the insulation walls. Now before creating the Endcaps, it is necessary that we create these Endcaps with the polyline, because normal lines will not be recognized by the program. So we'll create some of the geometry here. Before starting, we can check our definitions. That for the wall I have the thickness 200 mm wall, and for the sandwich and insulation I have 270 and 340. So we'll start with the solid wall, and I will just start creating a geometry. I'll just add the nominal dimensions here. Okay, this is okay, and if required we can maybe add a recess or something on the one side of the panel, so maybe 15 mm. Okay, that is not okay. We'll add 15 mm here across. We will give it the thickness of 60 and again close it, and we will add this to our regular geometry. Okay, and I will just join these two lines. So now we have this polyline, and we should give it some dimensions. I will just add some dimensions here, and I will just resize them afterwards. And just the thickness that is missing here, I will just resize these all. Okay, that is much better. So as you can see, we defined the geometry for the end cap, and we also mention some of the dimensions. So for defining end caps, we go into here in the components, go to we are defining for the solid wall, so we will select the wall and we will create a new. Now being a solid wall, I would give it maybe designation V20-01, 20 being the thickness of the wall and 01 just the starting number. In the description, I will be using this endcap for the corners, so I will give it the corners. Okay. Now here we'll first go into the level 1. We'll select. Okay, just a second. It already has the geometry, so we will add the new one. We'll give it W20-010. Yeah, that will do. Okay, so we have two level of details here. So level 1 is when we need to represent this end cap in the shop drawings, and level 2 will be whenever we find the preview for selecting this end cap in multiple windows for the project. So we'll start with the level 1. For the level 1, we will add all of this geometry along with the dimensions because I want to show them in the shop drawings. I'll select the base point. You can see it is added. And for the level 2, it is fine by me if I only choose the geometry. So I will just select this, press enter, get the origin. Now as you can see, program already picked up the geometry for this end cap, but if we want to be sure, maybe we can add, select this polyline again and it will be added. And we have the option to select this reinforcement boundary. Now it is often time that we want to make sure that sufficient cover is added, so we can add the reinforcement boundary. We have the two options to define boundaries, either by the polyline or by the points. We'll select the points for this one. So I'll just select 15. Again, I'll select the distance of 15 from here, and I think I will choose around here. Okay. Now as you can see, this red line represents the reinforcement boundary for our end cap, and no reinforcement will be placed outside this boundary. Okay, we'll just click it OK, and it is added to the database. Now let's apply this to the solid wall. We have this one, and we will just edit this wall. We'll go into the properties and we'll go into the end caps, and the left and right I will choose this particular end cap. As you can see, the preview is added here. I'll just flip this for the current orientation. Okay, I have added the wall end caps, and I will just update the wall. As you can see, the geometry of this wall is modified to accommodate this end caps. And if we want to take a look, we'll just look at this from the 3D perspective. As you can see, this recess goes throughout the wall. Now we'll quickly generate, first we have to save the wall, and we'll quickly generate the shop drawing for this wall. WP1 is okay. It will maybe take a minute. Okay, that's done, and let's generate the shop drawing. I will select a different template for this one. Maybe that is not the correct one. Okay, now it will take maybe a few seconds, maybe 20-30 seconds, but for the number of shop drawings, it really helps to just automate the shop drawings. Once our template is fixed, we can generate maybe 50-70 shop drawings at one go. We'll just open up this wall shop drawing. Okay, it is almost done. So as you can see, we added the geometry at the this recess for the end caps, and being on the far side of the wall, it is shown on the dotted lines. We can see the section up here, and we have this one. The left and right end cap labels are added in the plan section, and if we add the end caps for the top and bottom of the wall, it will be shown on the side section. Now being the level 1, it will must have be added here. Now we have the level 1, that is exactly how we define. Now if we look into the layout which we like to print, we have our wall. I think we are missing the viewport. I will just add it quickly. New viewport, I'll select this one. This is the viewport we are adding for the end caps, and align and scale. Okay, if we just get back into the layout, yeah, as you can see, we have our layout here, the end cap, and this is our shop drawing. So this was for the solid wall, and similar process we can do with the other walls. Now to save some time, I have created some of the geometries. I will just open those up. As you can see, we can add multiple geometries at the end of the wall and it will be available. So we will quickly define this wall, this end cap. Go into the plan, we'll go into the end cap and we'll create a new one. Now being a solid wall, add new P20, it already took the next number. Okay, and we'll select for the level 1 and the jump and the origin, and for the level 2. Okay, yeah, and being the reinforcement boundary, I will select this one line as this. Now we also have, as you can see, there is some line here. If we require to produce some conduct or maybe a duct, electrical duct, along with this end caps, we can add this into the custom material. Now we can simply add, we'll be scheduling this in the shop drawing, and it will be scheduled according to the length of those recesses or the ducts. So I will just add one of the maybe 271. Yeah, added the recess and it will be emptied along with this end cap in the shop drawing. So again, in our floor plan, what we can do is we can go into our previous shop drawing and we will just redefine this element to have that end cap. So for the left and right, I will just change these two. Okay, we'll be redrawing this. Yes, and we'll be updating the lift as well. Okay, now you can see we added the new geometry here, and if we go into the schedule, the linear footage that we added, okay, it overlapped just a little bit, I guess. Okay, the linear the custom metal that we added, it is added here, and the pieces, this 5.2, it is the in meters because we added on the left and right side of the wall, and being 2600 height, twice that is the 5200, so 5.2 meter of this, and this linear sim will be required. Okay, now we can show you how to define the end caps for solid walls, sandwich walls and the insulated walls. So I have one of this geometry for the sandwich wall, and I have this definition for the 340 mm sandwich wall. Let's just go into the end caps, choose sandwich, I will create a new one. Being a sandwich, I will give it maybe SW340-010. Yeah, and it will probably be used on the top side of the wall, so I will give it the description as top. So again, the level 1 will select this complete geometry. Insertion point will be here, and for the level 2 we'll only select this much. Okay, again origin will be here. Now it is added. As you can see, we need to define this layer boundaries for upper and lower panel, and we'll do that from here. First we'll define the reinforcement boundary. It will be again this one, this particular polyline here, and we'll select the layer boundaries. As you can see, specify the boundary between inner panel and the insulation. So our inner panel and insulation will be here, separated here. We added that one. Okay, it is now defined properly, so we'll do it again. So inner and insulation, and then inner and outer panel, which is this one. As you can see, we have added the layer boundaries. Now if required, if you want to add another insulation that is different to the definition that we have added, you can define it from here. And here again we have the facility to choose the polyline, or we can go with the points. I will go with the points on this one. So I'll choose the vertices for this different insulation. Just close it, and the orientation of the hash line will be from here, and I'm done adding the material. You can see this one is added here. So this insulation, what we need, I think I will add is the polystyrene. So this insulation will be defined with the polystyrene type. I will click OK. Okay, and again we go into the floor plan. This is our sandwich wall, so we will define with this one. So we'll click edit this wall, and we'll go into the properties. We'll select the Endcaps. As I told you, it will be for the top, so we'll add it for the top. Okay, and we'll update. Now in this particular wireframe view, you can't see the geometry that is modified, but it is due to we need when we are looking from the top, it needs to be plain, not through all three lines in between. So that's why in the wireframe it shows the complete box, but we can check the solid type. As you can see, the geometry of the wall is modified along with the different insulation at the top. Now, like the previous one, we'll quickly generate the shop ticket for this one. Just save this, and SW1, that's okay, and generate the shop drawing. Again, I have the template here. Okay, it will maybe take approximately similar time as the last one. Look, yeah, it is almost done. Yeah, let's open up the shop drawing. As you can see, we have the end cap detail here correctly represented, and we are showing the end cap label on this section. You can see it has morphed correctly, and this particular we can check the 3D drawing for this one. Can see here we have the different insulation for the top material that we define. So it's an option that if you want to add the different material or not, it completely depends on your factory's manufacturing process. Now I have one more of the sandwich wall. where we can add the reinforcement in the Endcaps. So we'll quickly, okay, for the reinforcement maybe we'll just look at this after the insulation wall. Now the insulation wall is almost similar to the sandwich, but instead of choosing two boundaries, we only have to choose the one. Again, go into the Endcaps, we'll switch to insulated wall, we'll add new, and I would give it IW 270-010. Okay, we'll go into the one which is completely, we'll get the origin, and for the level 2 again the same thing without the labels. Okay, the geometry is added, we'll just select the layer boundary, which is this one. You can see. Okay, and okay. Now here before defining, I should tell you that geometry of the wall should be one polyline, and the layer, the separating layer between the inner and the insulation, the panel and the insulation should be one complete different polyline. So we can again apply the same thing in here for this our insulation wall. Okay, so I talked to you about the reinforcement. We'll quickly add it. I have this reinforcement, I'll shift it to the one that we already have. Okay, so what we're gonna do is edit our previous Endcap and we'll add this reinforcement in it. Again, I selected this bar, can be any shape that you like. I just chosen to be the U shape. Again, choose the base point. Okay, it is added. We'll click OK, and if we go back into our shop drawing where we had this, for applying this reinforcement we have to check which reinforcement template we have applied. It is WA001. So if we go into the reinforcement template, WA001, we'll edit this, and if we look into the edge reinforcement, we have Endcap reinforcement, and I have added the spacing for top, bottom, left and right to be 250. So the reinforcement we just added in the Endcap will be adjusted according to this particular spacing. So let's just go back in the top view, let's generate the reinforcement template. Okay, and as you can see, the bar that we added in the Endcap is mentioned here, and if I at the distance of the 250, and if we just expand the distribution line, you can see we have added it in the top part of the wall. It is also must have been added here, being 25, yeah, already it is also already added in our schedule. So that was for the Endcaps and the reinforcement along with the CIM that we added in the panel 1. So we'll look into, I will just close all of this extra ranks. Now we'll look into the CIM template so that we can add the CIM at the specified distances very quickly. In CIM template we create a generic layout how we want the CIM in the wall or maybe in the element, and we'll just apply. When we press apply, it will accommodate according to different wall sizes, you can say. Yeah, we have a similar process as the solid wall for the solid slab. Okay, now we will go into the CIM template, which is here, template. I will create a new one. I will give it, maybe I will creating for the CIM, I'm creating for the 241, so I will give it that name. Now we have the 3 layers here. The table of CIM, this particular level is for the walls, the second layer is for the hollow cores, and third is the dynamic and CIM dynamic. So for this one we will only add for the walls and the hollow cores. So here I will add the new end cap. I will select for the sandwich walls, maybe here we already the one we created, and I will add the CIM here, that is 241. Okay, here is our connection loop. We just have to adjust it according to the distances or the end cap, so we'll do it quickly from here. Okay, sorry, I pressed enter. Okay, 270, we have moved that. I would like it to be rotated 90 degrees, and then I will just move it in the y direction by 40. Okay, maybe a little bit lesser on the x direction. Okay, that is okay, perfect, and we'll just click OK. And we have to define how we want to place this. For placing the top, we have this A, B and C dimension for the setup one. Now A and B should be from the left and right side of the wall, and the C it adjusts in the middle of it. So we'll choose, we can keep it default according to our requirement. I will choose it to be 400, and in between I will go with maybe 500. Okay, this is one of the setups, but if we want to change the different one, in here we can say that I want how many specification. So if the total length is L, we will place this CIM at the L by A or the L by 4 distances. So we'll go with the first one. Okay, we can do the similar adjustment for the placing bottom, left and right. So let's get to it. Okay, and what we are going to do is we're going to our walls, and we'll already have the applied for the top one, but for the sake of it we'll use this different wall. We'll define that particular end cap on the right side and the left one. According to our definition, I should have only applied it to the top, but for time being, for the CIM template, we'll just do it for this one. Okay, we'll update the wall, lift and pressings, and exit. Now for applying the template, I will go into apply template and select the wall, and the applicable, the CIM 241 is available here. Okay, as you can see, this particular CIM that we added in the CIM template has been added, and we will apply the same thing for this wall as well for the top side. And as you can see, it is added in the 3D as well. If we open up this shop drawing again, we have to save it first, so just a second. I'll just go in here, I'll save this shop drawing, this element real quick. Yes. Okay, it is saved, and now I will just redraw this whole production drawing, and all the changes will be added here. It will take a few seconds, but still it is pretty fast. As you can see, our CIM that we applied to the template is added here. Now what we saw in the template was we defined it according to the end caps, but there is also option that you can we will add a new one in the same template, and we can define it by the left, right, top or bottom side of the wall as well. So it is not necessary so you add this at the end cap just to apply the CIM template. Maybe I can show you just real quick. I will add a new one. I'll choose 271 and I'll choose the left side of the wall, and okay, it is not chosen. Let me just search here. Okay, we will look at it maybe in a later date because we are constructed by the time. So that was it for the CIM template, and we will quickly look into the hollow cores. Now I have some of the hollow cores here. I'll just quickly show you in the solid view. I think, yeah, let me check. We have this hollow core, otherwise we will draw a different one. Maybe we should draw a different one. Yeah, I'll just click draw hollow core. Okay, I'll choose the window for drawing this, apply, and I'll give it no slope and continue and apply. Okay, now we can apply the same template for this one also, or we can create a new one. So here we can go into this one. Okay, but we haven't redefined the end caps for this ones. For the hollow cores, we'll just quickly do that. For the hollow cores, again we will go into the similar process. We'll go into the end caps, we'll choose hollow core and create a new one, the sides. Okay, and select the geometry, select the origin, we'll go into the level 1 and select all of it. Okay, yeah, let me check, we haven't choose the geometry. I think we should go with the points here, but no, point won't do it correctly. We have to choose the polyline. Let me check if it's correctly drawn. That's why it was a block, not a polyline, so it couldn't choose. So we'll go into the end caps, again hollow core, new one, sides. Okay, we already have the level 1, level 2. We'll select the geometry, we'll select this, yeah, okay. Now the thickness of this one is 185, and let's see what we have for this one. I think we had 200, maybe that is why we didn't get it correctly. We'll just edit this, we'll go into the properties, okay, 185. and again we'll apply some of the end caps from here. So okay, this is strange. Okay, maybe we should cover the hollow cores maybe in the next next webinar, but this is it for right now. If possible, we'll just look into the solid walls, solid slabs. Going to the end caps, going to the wall slab and add a new one, solid slab. Again the similar process. I think we are having some issues with the hollow core, or maybe just I am, but I'll just figure it out for the next seminar. And we have got the geometry. Okay, and in here we'll apply it to the solid wall, solid slab. Into the properties, end caps, and choose as a slab, and I would like it to be on all around, so I will copy to all of this, all sides of this slab. We'll update the lifts and we'll exit. Now if we just quickly save this and generate the shop rank, we'll have the elevated edge for this particular slab. It will be particularly good in cases of the balconies. Generate the shop ticket. Okay, it is done. Let's open it up. So you can see this extra geometry, the height that we define in the end cap 45 is added in this whole slab. Even though main thickness of the slab is 200, this extra geometry is added to the end caps. And if we quickly look at the solid, this geometry can be useful for inserting or casting the handles on the side of the balconies. Unfortunately, we couldn't be able to show the end caps for hollow core, but we'll look into it and get back to you on the next webinar and presentation. And this is it for today. If you have any questions, you can go into the chat and send them to us. No questions? Okay, then if we'll maybe wait a minute or so, we can look into this end cap view in here in our model view. I'll update the project. All of the modification that we made to the geometry of the wall will be also reflected in the model viewer. You can see the end cap is applied to this wall and represented correctly. We have the one with the solid walls, that the recess for the connections, and we'll have this balcony with raised edges. Aniket, can you check if we have any questions? Okay then, that is it for today then, and this video also be available on our StruEngineers channel on the YouTube. And if you miss anything, you can always check that out. And thank you for joining, and that is all. Take care, stay home.